Let us check this question from Hooke's law. Figure shows a spiral spring whose unstretched length is 0.1 meter. A student then hangs objects of different masses from the spiral spring. Figure 2 shows the spring when 1.5 Newton is added, and figure 3 shows the spring when an unknown weight W is hung from it. Now let's check the figure here. The first figure, figure 1, is an unstretched spring. That means no weight is added to it. And figure 2 is a stretched spring with 1.5 Newton added to it. And the figure 3 is also a stretched spring with an unknown weight is added to it, and it is stretched to 0.55 meters. Now let's check the question. By how much is the spring extended when the 1.5 Newton weight was hung from it? So we have to find the extension here. So that is, we have to find E extension or delta L, the change in the length of the spring. So we can find by checking the length of the unstretched spring and by checking the length of the spring when 1.5 Newton is added. So that is 0.3 take away 0.1 meter, that is equal to 0.2 meters. That is the extension or the change in length. That's the answer for question number 1. Now let's check question number 2. Calculate the weight required per meter extension. So before going to that question, we have to find the spring constant. Spring constant here. So we know the formula to find spring constant. We know the formula for Hooke's law, that is F is equal to K times E. From this formula we can rearrange this to find spring constant, which is K. K equals F over E. Now we know how much is force here. Force is given as 1.5 newtons and extension is given as extension we find in question number 1, that is 0.2 meters. So we can substitute this on this equation for spring constant, that is 1.5 newtons divided by 0.2, which is equal to 7.5 Newton/meter. So this is our spring constant. Now we can come back to the question. We have to find the weight required per meter extension. So which means the extension here is equal to 1 meter, and the spring constant, we know how much is the spring constant, which is equal to 7.5 Newton/meter. So we know the formula for Hooke's law, F, force or weight, which is equal to K times E, which is equal to 7.5 times 1, which is equal to 7.5 Newton. So this is a weight required per meter extension, that means for 1 meter extension. Now calculate the weight which causes spring's length to be 0.55 meter. So what that is given here is spring's length, not extension. So we have to find out extension here, that is 0.55 take away 0.1, which is the length of unstretched spring, which is equal to 0.45 meters. And we know how much is the spring constant, K, which is equal to 7.5 newton slash meters. Now we can substitute this in the equation. F equals KE, which is equal to 7.5 times 0.45, which is equal to 3.375 newtons. So the answer